Hi guys, we're back for another lesson in chapter 8, and I have another tool for us today. Bummer that I'm not in class because this is a fun one. But with COVID, we couldn't do this the way we're supposed to anyhow. But you should have this worksheet, lesson 8.2, day 2, how much of the earth is covered by water. If you don't have that opened up and ready to enter into, pause the video and go get that worksheet, okay? If we were all in class, this would be so much fun. In order to get this activity going today, we would have been tossing this beach ball that is a globe of, our world here, and we'd be tossing it around. And where our index finger would fall in the right hand when we catch the beach ball, then we would say, oh, is that water or is that land? So my index finger's on water, so we would record water, 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 land. Okay, so anyhow, that's what we would be doing. So in order to be prepared for today, I had my son help me out, and I tossed this ball 100 times. Yes, 100 times for our sample. So if you want to go to question number 1, how many locations did your class sample? Well, Mrs. Straub took care of tossing this silly ball 100 times and recording where my index finger fell. And how many locations were water? It was 61. So 61 water, 39 land when I was playing with this beach ball. Okay? Like, I could just see you guys having a lot of fun with this, but unfortunately, Mrs. Straub got to have all the fun this time, okay? All right, so what I want you to do with this is calculate your p-hat from that. I did 100 on purpose to keep this a little simple, so it should be just 0.61. But now what you're going to do is construct a 95% confidence interval, and I say CI, right, so that I'm not saying all those big words lots of times, but CI, to estimate the proportion of the earth that is water. Well, of course, we know an answer to this if we go look it up, but this is to see, let's see what we got, okay, from our sampling. If you recall yesterday, I gave you a template that I want you to be following, and AP wants you to follow: state, plan, do, and conclude. And so this is a copy of that worksheet template. I want you to fill in your state, plan, do, and conclude for that activity as a review from yesterday. Okay, and when you're done with that and putting in some answers into Edpuzzle, we'll come back and look at the answers to it. Okay, welcome back. Here is what we had, 100 tries. Sorry, I had to use this little mouse to get these in here, but ours was 61. Okay, so what we should have here is that P is the true proportion of earth covered by water. Remember, we need to put the parameter. Proportion must always be there. Right now we're doing proportions. When we get to means, you'll be putting mean in and saying that it is P, that is the population parameter, right? Proportion. So all those words should be there to get your parameter identified. And then what confidence level are we doing the CI? We're constructing a 95% CI. So what is the name of our procedure? It's a one sample Z interval for P, for proportions. You could say for proportions as well. They are requiring that you put the procedure down now as we go to all these inference strategies. And this is our first inference strategy, is to create a confidence interval with one sample Z score for proportions. Okay, because you will do a Z-score for means, sort of, and we're going to talk about that when we get to means. Mostly you do a T-interval for means, and we'll talk about that too. So checking conditions, remember, you must check all 3. Random. This was a random tossing of the ball. I just tossed the ball, and if we'd been in the class, it would have been random tossing it around the room, and whoever caught it would say whether it was water or land, and we would have recorded it. Lots of fun that we're missing out of because of COVID. The 10% condition, this is taking 100 is definitely less than 1/10 of all the possible locations my finger could have fallen on that big old globe beach ball. Okay, and then the large counts, Did you do NP? So 100, our large counts would be 61 and 39 for N for 1 minus P hat. So that would have been, I guess I should have put that note there. Add note. So this would be 61. See if I can fit it in here. 61. And this would have been 39. Right? Okay. The general formula, right? The general formula is your point estimate plus or minus the margin of error. The specific formula for what we're doing is P hat plus or minus Z star times this. Okay, this is on your formula sheet. This standard deviation piece, which is also called the standard error of the sampling distribution, right? So I plugged in the numbers here for us, and this is the CI that I got. Hopefully you did too. I'll go check in Edpuzzle. But then your interpretation to finish it off, we are 95% confident that the interval from 0.5144 to 0.7056 captures the true proportion of Earth that is covered by water. You can go look it up and see if we were right. If we're super confident from the way that ball went. That's kind of an interesting question. What percent of Earth is covered by water? Okay? All right. We're going to go to notes now to finish yesterday's notes. And you're going to be happy, if I can get it to come up here. And let's present from current slide. Okay? There is a calculator command for doing all the work. I wanted you to do it by hand first yesterday. And now if you wish to switch to a calculator command, it is the one prop zint is what it's called. In my calculator, it just says Z interval in the older ones. So you could see it might say one prop, that's one proportion Z interval, or just Z interval. Okay. Let me see here. Nope, I lied. That's the means. Let me go to, so you hit the stats button, okay? It shows you here, you hit stats, and then you choose tests from within stats, and you go to, let's see, there it is, one prop zint. There we go, you're right, one prop zint. Okay, so the one prop zint either this way, or this is more of a maybe an 84s screen here. And then you just need to put in your X value, your N value, and then what confidence level you are doing, and hit calculate, and you will get back the interval. It'll tell you what P hat is, so you don't have to go do that division. It'll even give you P hat and your N back, and then you can take those values and interpret them. So if you're doing this, you need to put into your paper this screen that I'm surrounding here. You need to show what your input window is. So you need to show X, N, sea level. You don't have to hit calculate, but you need to hit the other things that you're entering and their labels. And then you need to put output. I really try to train my students to do input, output. So input would be this first screen, and this is your output. And put that on your paper if you choose to use the calculator for this. Okay? Input, output screens I'll be looking for. No, you cannot just go to the calculator and give an interval. They will not give points. Neither will I. So let's see if we can move on here. Seems like I moved backwards. What's going on here? There we go. There we go. All right. One other topic that you need to know how to do for this is, like, let's say, okay, we are planning a study now. We don't know what our N is. As a matter of fact, we know, though, that when we do this study, that we need to be within a certain margin of error when we are estimating that parameter, or it's not going to be a valid situation for us. Like, we need to know within 2 percentage points what the truth is, or within 3 percentage points what the truth is, and I can't go beyond those barriers, or else it just really isn't meaningful or isn't precise enough for us. So we may need to try to figure out, well, what sample size should I get in my survey or take in my experiment to allow me to do that within that certain margin of error that I need. Okay, so remember that the margin of error formula is that critical value, whatever z star is for 90, 95, 99, times our standard error, right? So if we know what margin of error we want for our confidence interval, and we know what, well, we're going to talk about what if we don't know p-hat. We're going to talk about that soon. But we know maybe our p-hat is, but we don't know n, then we can plug everything else in here and solve for n. Okay, so let me move my face out of the way so we can see this. So we're going to calculate by substituting in for ME, Z star, P hat, and then solve that mathematical equation for n. Okay. Now, we won't know the value of P hat, though, until after the study has been conducted. You probably already wondered, well, where would I get P hat if I haven't done this study yet? Okay, so that means we kind of have to guess at the value of P hat to choose n and do it our best effort, but we also want to do it the most conservative way. We don't want to underestimate and end up having invalid answers. It's always better to be more conservative and sample more than you have to in order to get what you want in your results. Because remember, sampling more actually gets you closer results. But sampling more also costs money, so they need to find that balance. So here's a couple of things that you could do. You either use a guess for p-hat based on a pilot study that was done, or maybe past experience with similar studies. Then you would just say, well, in the past, this has been about 38% or 40%, and you could use that. Okay. But most of the time, if we're trying to find the sample size first, remember, this is going before the study is done. Everything we've done so far gives you the study is done, and it says 120 out of 300 people said this, right? We don't have any of that now. We don't know what n. We're trying to figure out, well, how many should I sample? And then I don't even know the results. So what we do is we use, as you can see here, 0.5 as our guesstimate in that formula, because 0.5, that will make that margin of error the largest possible. Put in the other values for p. 0.5 times 0.5 is 0.25, but you start going into other things there, and you're going to get, excuse me, getting late at home tonight, you're going to get a smaller margin of error. So we're going to be the most conservative possible and make that margin of error as large as possible. If we get any other p-hat when we do our study, the margin of error will then actually be smaller than what we had planned. So we're saying we're going to take the largest margin of error possible for what we want, and then actually if it's anything other than 0.5 when we actually do the study, our margin of error will be smaller, and that's good. It hones us in more onto the truth, right? All right, so again, you set up the formula like this. You want this margin of error to be less than or equal to some maximum margin of error that's given to you, and you solve for n. And if you don't know what p-hat is or should be based on past, then you use 0.5. So let's go ahead. This is just repeating what I just said, so I don't know how we move backwards. Let's do an example, choosing the sample size. So a company has received complaints about its customer service. The managers intend to hire a consultant, and before contacting the consultant, the company president wants some idea of the sample size because she's going to have to pay for it, right? So one value of interest is the proportion P of customers who are satisfied with the company's customer service. She decides she wants to estimate the estimate to be within 3 percentage points, which you know that's 0.03, of the truth at a 95% confidence level. So how large of a sample will she need to get? And now remember, she's going to want to get it large enough to get her good results, but also know where she can stop so she can save money on that. So we're going to set up the formula. The critical value is Z star from France, right? Z star is 1.96. And then you have the square root of p hat times 1 minus p hat. Since we don't know what p hat is here, we're going to use 0.5. And then hopefully your math skills from the past will kick in. In order to solve this type of an equation, you know you need to divide by both sides of the equation by 1.96 first. Then you're going to want to square both sides to get rid of the square root here. And then you're going to cross multiply and solve for n. So let's do the next step. We divided by 1.96. Square both sides. Okay. And then what this side did here was multiplied both sides by n. It's kind of like a cross multiplication situation. So if you just multiply both sides by n, you get this. So now to solve for n, you're actually going to take this side and divide by that side. And we get a number. Now pay attention to this part. This number is a decimal, so obviously you're not going to sample portions of things or items, but we do not round down. Remember, we're wanting to be conservative, the most conservative possible. And so what we're going to do here is we're going to take 1068. No matter what this is, we round up to the next integer for our answer. So you're going to tell this boss that she would need to at least speak with 1,068 customers in order to stay within 3 percentage points. Now remember, we use 0.5, and so if half the people are satisfied and half the people are not, then we're right on there. But let's say hopefully more than 50% are satisfied with her company and it's more like 80, then this margin of error will actually be smaller than that 3% max that she wanted to put on it. Okay, so that just explains here why not round to the nearest whole number, which would have been 1067, because remember, a smaller sample size will give you a larger margin of error. We're trying to be conservative here, and we don't want to go over that 3 percentage points, which that would put us slightly over 3% if we rounded down, and these percentages were close to 50%. So I just wrote here, always round up to the next integer. Okay. And that's that for notes. So what I want you to do now is to go back to that Earth worksheet. Oops, I didn't want to show you the answers yet, Mrs. Straub. And I want you to go to the second page of Check Your Understanding. So this is the one that we just now took a look at, and I'd like for you to write it out. It's similar. She wants to stay within a 3%. Okay, so remember, you're going to use the conservative estimate and find how large of a sample size is needed. So do the math there to come up with that. I kind of sort of gave this away, but in the company's prior year survey, 80% of customers surveyed said they were satisfied. So because we have a previous study or a survey, instead of using 0.5, which was the conservative estimate, now go back in and do it with 0.8. And use that, find the sample size that would be needed for a margin error of at most 3 percentage points there. So I showed you in the notes how to do number 1. You're going to now just change 0.5 to 0.8. And then, of course, 1 minus p hat is going to be 0.2. And then I want you to compare that to what happened in the most conservative one. Like, what's the difference in the sample size? Then, one more thing for you to look at. What if the company president demands 99% confidence instead of 95% confidence? Would this require a smaller or a larger sample size, assuming everything else stayed the same? So now go look at these and say, if my Z-star changes from that 95%, 1.96, to 99%, I think it's 2.576, something like that. You can go look it up. If that changes, what happens to my sample size? If I'm going to be 99% confident, would I need to get a larger sample size or a smaller sample size to get that done? So I'm going to ask you to put these answers to 2 and 3 in Edpuzzle for me, and then I will come back and show you the answers to them, and we'll be done. Alrighty, so we already did number 1 together in the notes. Here's what you should have gotten for number 2, changing that 0.5 to a 0.8, and then you remember to round up always to the next integer. So look at that. If we knew that it's more like 80%, then she wouldn't have, look at how many people less she could have sampled. Remember, this is giving, that's what I'm trying to say, this 0.5 makes this the most conservative, and you would be sure to be within that 3 percentage points. Okay, but if you're pretty confident that you're not at 50%, that you're higher than that in your approval rates year after year, then you wouldn't have to survey as many people. It'd probably be okay. Right? Now, what happens if she wants 99%, which is what this 2.576 got changed here with our Z-star is different, leaving in that 0.8 and 0.2. Now look what we get. We get 1180. We go back up to even more than we had to here. So of course we're getting more confident that we're okay. Means that we got to get larger. Hopefully that made sense to you before you even did the math. We need to have a larger sample size to increase our confidence that we're going to be capturing that keeping within that 3% margin of error. I don't know. Let's see if I can move this. Yeah. So it just says the larger sample will make us right. So yeah, remember, the larger the sample, the closer we get to the truth anyhow, and more precise. And so that should make sense to you. Okay. You're doing your homework tonight, and I'll see you on Monday.